Let us solve the first problem. F of t is t for t between 0 and half. It is equal to t minus 1 for t between half and 1, and it is equal to 0 for t greater than 1. We have to find Laplace of f of t. So first we will see the definition. We will write the definition, which is 0 to infinity e raised to minus st into f of t dt. Now this whole thing is divided in three parts. First is 0 to half. 0 to half we have value of f of t as t. The second half is between half and 1, and here the value of f of t is t minus 1 into dt, and the last part is from 1 to infinity. 0 multiplied by anything is 0, so we say that 0 into dt. Now this first part we apply u into v, so it will be t into e power minus st whole divided by minus s, then minus derivative of t is 1, then e raised to it is minus st upon minus s into minus s is s square. Then if we differentiate 1, we will get 0, so we will not go further. Limit is 0 to half plus t minus 1 e raised to minus st upon minus s, then minus derivative of t minus 1 is 1, so 1 into e raised to minus st upon s square. Here limit will be from half to 1. So we put upper and lower limit. So first here, when we apply the upper limit, in place of t we will put half and divide by it is minus s, so we will say that minus 1 upon 2 e raised to minus s into half s also we can say, so better I write e raised to minus half s divided by s minus e raised to minus half s divided by s square. This is upper limit minus lower limit. We put 0 in place of t, so we get minus e power, because the first term is 0, e power minus 0, so minus 0 is nothing but 0 upon s square, then plus the second bracket. In place of t, when we put 1, we will get the first term as 0 minus e power minus s upon s square, minus we put half in place of t, so it is half minus 1 into e power minus half s upon minus s minus e power minus half s divided by s. The limit will be limit already we have provided, so just I close the bracket, and then this will be equal to, first I will write all the terms which have e raised to minus half and denominator as s. S or minus is one and same thing. So I have first term in the beginning, so I will write this as minus e raised to minus half s upon 2s. Then I have this term. When I open the bracket, this will be minus half, and this minus 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 is plus, and again I have minus, so I will write minus e raised to minus half s upon s. Then I have e raised to minus half minus e raised to minus half s upon s square. Then we have this third term e raised to minus half, so again it is minus, but it is e raised to minus s, so this last term minus minus plus e raised to minus half s upon s square. Then we have one term called e power 0 minus minus plus, so I will write this 1 upon s square, and then I have one term e raised to minus s, so minus e raised to minus s upon s square. Now this e raised to minus half s upon 2s, and this is e raised to minus half s upon s. When we add, we will get minus 3 divided by 2 e raised to minus half s upon s. Then this term and this term will cancel, plus we have 1 upon s square minus we have e raised to minus s upon s square. This is equals to, I will write this first, this 1 upon s square, then minus, it is 3 divided by 2 e power minus half s upon s minus e power minus s upon s square. So first problem done. This is Laplace of f of t for the first problem. Now let us move to the next problem. Next problem is f of t is equal to sin 2t when when t is between 0 and pi, and its value is 0 when it is between it is greater than pi. The solution, again, Laplace of f of t is equal to 0 to infinity e raised to minus st into f of t dt. This will be equals to, I will split between 0 to pi, it will be e raised to minus st into sin 2t into dt, plus from pi to infinity the value is 0, so I will say simply 0 is equals to, now this e raised to minus st into sin 2t integration, we have already seen the formula. This is e power minus st upon s square plus 2 square. 2 square is 4, I can write directly 4. This is one term and this is another term which I have taken here. Now here it is minus s into sin 2t minus 2 into cos 2t, and the limit will be between 0 to pi. So for this whole, my limit will be 0 to pi. First we will put the upper limit, which is pi. So it will be e power minus pi s divided by s square plus 4. And here first I will put the value of t as pi. So minus s into sin 2 pi minus 2 into cos 2 pi. Upper limit we have applied. Now minus, we put the lower limit. So e power 0 is 1. So it is 1 upon s square plus 4. Then here in bracket minus s into, it is minus s into sin 0 minus 2 into cos 0. This will give me answer as e power, we get e power minus pi s upon s square plus 4. Sin 2 pi is 0, so this answer is 0, minus cos 2 pi. Cos 2 pi is same as cos 0. So cos 0 is 1. So I have minus 2 minus 1 upon s square plus 4. Again sin 0 is 0. So this is 0 minus 2. Cos 0 is 1. So the final answer is minus 2 e raised to minus pi s upon s square plus 4, then minus minus plus 2 upon s square plus 4. Now we can take something common. What we can take common? We can take 2 upon s square plus 4 as common. So here we say that 2 divided by s square plus 4 we have taken common, and this term I will write first as it is positive. So 1 minus e power minus pi s. I hope now you are finding that the Laplace transform is easy to calculate. Now let us move to the next problem. Third. So this is third problem. F of t is equals to t for t between 0 and 3, and its value is 6 for t greater than 3. As the function is very simple, I think the solution is also going to be very fast. Laplace of, we will start with the definition. Laplace of f of t is equals to 0 to infinity e raised to minus st into f of t dt. Okay, so here we will split in two parts. One is between 0 and 3. It is e raised to minus st into t into dt, plus the other part will be from 3 to infinity e raised to minus st into 6 into dt. Now this first part, so u into v, so t into e raised to minus st upon minus s minus derivative of t is 1 e raised to minus st upon this is going to be s square. Limit we will put, this is between 0 and 3, plus 6 times I have e power minus st upon minus s, and limit here is from 3 to not defined. Now this will be equal to, first we put the upper limit. So in place of t we have written 3 into e power minus 3s upon minus s. Now this is minus e power minus 3s upon s square. This is my upper limit minus lower limit. So when I put 0 in place of t, so this first term will be 0 minus e power 0 is 1 upon s square. Then this second half is 6 times, when I put infinity, so e power minus infinity is 0 minus e power minus 3s upon minus s. So this will be equals to, e power minus 3 upon s. We are seeing at two places, so we club them. So what I say that minus 3 into e power minus 3s upon s, and then it is plus 6 into e power minus 3s upon s, then minus e power minus 3s upon s square, and then minus minus plus 1 upon s square. This will be equals to, now this is minus 3 and this is plus 6, so minus 3 and plus 6, the result will be 3 times e power minus 3s upon s, then minus e power minus 3s upon s square plus 1 upon s square. We can take some common terms out. So what we can take out? E power minus 3s upon s square, suppose we are taking out. So here we have 3s minus 1 plus 1 upon s square. Done. Now move to the fourth problem. Fourth problem is f of t is equal to cos t when t is between 0 to 2 pi and its value is 0 when t is greater than 2 pi. So what we say that Laplace of f of t is equal to 0 to infinity e raised to minus st into f of t into dt. Now here we will split in two parts, 0 to 2 pi e raised to minus st into cos t dt, and the second part is going to be 0. So this is, again we know the formula, it is e raised to minus st. Always when e power and cos is there, upon here it is s square plus 1, in bracket we will write minus s into cos t plus sin t, and the limit what we have to put is 0 to 2 pi. Now this is equal to, when we put 2 pi, so here we get e power minus 2 pi s upon s square plus 1, here minus s into cos 2 pi plus sin 2 pi minus e raised to 0 upon s square plus 1. Then I put 0, so minus s into cos 0 plus sin 0. This will give me result as, now e power minus 2 pi s, that it will be upon here it is s square plus 1. Here what we can say that cos 2 pi value is 1, so I will say that minus s sin 2 pi is 0. So forget it, minus e power 0 is 1. So 1 upon s square plus 1. Cos 0 is 1, so again it is minus 1. So the final answer, now minus s is here, minus s is here, upon s square plus 1 is here. That whole thing I can take common, so I will say that minus s upon s square plus 1, and in this bracket I have e power minus 2 pi s, and this will be minus. What I will do, I will move this minus sign inside, and the result will be, so what we say that this is equals to, if I move this minus sign inside the bracket, it will be s upon s square plus 1, and this minus will become plus e power minus 2 pi s. Both are right, whatever answer you want to keep. Now next move to the fifth problem. F of t is t square for t between 0 and 1, and its value is 1 when t is greater than 1. So what we say that Laplace of f of t formula is 0 to infinity e raised to minus st into f of t dt. This will split in two parts. One is 0 to 1, it is e power minus st into t square dt, plus this is 1 to not defined e power minus st into 1 dt. The first part, u into v, we will apply to t square e raised to minus st upon minus s minus t square will be 2t e power minus st upon, it will become s square plus 2. Now 3 times we have differentiated here, minus st upon this s square with minus s will become minus st, and the limit what we get is 0 to 1 plus the next part is 1 into, so it is e raised to minus st upon minus s, and limit will be from 1 to not defined. Now this will be equals to, we put the values. Now in place of t square, what we put in place of t, we have to put first 1. So I will say that this is 1 into e power minus s upon minus s minus 2 e power minus s upon s square plus 2 e power minus s upon minus s cube minus lower limit we have put. So t square will become 0, minus t will become 0, and this is minus 2 e power 0 is 1, so 2 upon this will be s cube. Now this will be equals to, okay, there is the second term which is plus. Now e power infinity is 0, so 0 minus, but we say that 1 upon minus s is equals to, now e power, we open the bracket, so it is e power minus s minus we will put here, then it is minus 2 e power minus s upon s square, then it is minus 2 e power minus s upon s cube, everything is minus, this minus minus it will be plus 2 upon s cube, and this plus 1 upon s. So finally what we will get is equals to, now here e power minus s upon s nowhere, so I will start with a positive term. So we begin with this 1 upon s plus 2 upon s cube, now minus e power minus s I will take out, so I have one term as 1 upon s minus 2 upon s cube, and then minus e power minus s we have taken out. Okay, three terms we can write. Everywhere this e power minus s is there, so what we can say that 1 upon s minus we have taken out, so plus, here it is plus 2 upon s square and plus 2 upon s cube. Now let us solve the last problem. F of t is 0 for t between 0 to pi, and sin square t minus pi for t greater than pi. Laplace of f of t is 0 to infinity e raised to minus st f of t dt. Formula first we will write. Then as 0 to pi its value is 0, so we say that this is pi to infinity e raised to minus st sin square t minus pi dt. Now we know the formula for e raised to minus st, sin t or cos t, but for sin square we have no formula. So first we convert the sin square t minus pi to sin or cos function. We know that 2 sin square theta is 1 minus cos 2 theta, or sin square theta we can say that 1 minus cos 2 theta upon 2. So therefore this integration will become pi to infinity e raised to minus st 1 minus cos 2 times t minus pi whole divided by 2 into dt. Now if we open the bracket, 2 will multiply by t, so it will become e raised to minus st 1 minus cos 2t minus 2 pi into dt. Now the value of 2 pi is 360 degree, it is a complete circle. So we have formula that cos theta minus 2 pi or 2 pi minus theta is same as cos theta. So therefore it will become half pi to infinity e raised to minus st into 1 minus cos 2t dt. We will open the bracket and split the limit as half pi to infinity e raised to minus st dt minus half pi to infinity e raised to minus st cos 2t dt. We can simplify this as half e raised to minus st upon minus s, integration of this e raised to minus st minus half of e raised to minus st cos 2t is formula e raised to minus st upon s square plus 4 into minus s cos 2t plus 2 sin 2t. Limit is pi to infinity. Now, when we put infinity, e power minus infinity is 0. Therefore, we say that 0 minus, we put the lower limit. After putting the lower limit, we know that cos 2 pi is 1 and sin 2 pi is 0. So, we get the answer. A raised to minus s pi upon 2s plus half a raised to minus s pi upon s square plus 4 into minus s. And finally, we take e raised to minus pi s upon 2 common, and we can say that it is e power minus pi s upon 2 into 1 upon s minus s upon s square plus 4. So this is how we solve problems based on definition. Now using these definitions, we will derive some formulae, or we can find out Laplace transform of some standard function in the coming lecture.